So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of trigonometry with a focus on the exact values of trig, going over what it is you need to revise, the actual trig ratios you need to remember before going through some past practice exam questions. Now as always I'll include a copy of the question we go through in this video available for you to download and have an attempt at, and all you need to do is just simply click on the link in the description below. Now before we get started working through some past exam questions all related to the exact values of trig, let's just have a recap of what they actually are. Now you are expected to know certain trig ratios without the use of a calculator in its exact form, and that be it either as a fraction or a surd, or in some particular cases as an inter of 0 or 1. Now this will enable you to achieve accurate answers because there'll be no rounding involved to trig problems, but also answer questions on trigonometry on, unfortunately, the non-calculated paper because they do appear. Now this method in answering trig questions should not change the method of how you answer a trig question, but merely the fact that you won't need your calculator. So that's the only main difference. Now in terms of learning the trig ratios, there are many different ways of remembering them. So you can either remember how they were formed by looking at isosceles and equilateral triangles, or you can look at, there's many other videos where they teach you rhymes on how to remember the trig ratios. But either way, or you can just learn them as a spelling, as you would a spelling test, and just know them and recall them off the top of your hand. There's also a method of where you can learn the trig ratios using your fingers. So again, loads of different ways. All you need to do is on Google or any of your search engines that you prefer to simply Google how to learn the exact values of trig, and hopefully you will get there. Now in terms of those different ways, there are several different variations of the trig values which are going to be acceptable, and it all depends on what makes it easier for you, because as you can see in the two tables that I've got on the screen, that with some of the trig ratios they are written slightly different. Some have got the denominator rationalized, some haven't, so they've got the surd in the denominator. Now depending on your question, it really does depend on which is going to be easier. Now personally speaking, with the experience I've got of answering loads of GCSE questions, I would say the one to maybe opt for is going to be this one. Now depending on how you have revised the trig ratios, it may be a case of where you know these values of where they're derived from. I don't know why those have slightly changed in indentation, but there you go. So it doesn't really matter whether you use the pink or the yellow. For the purpose of this video, I'm not going to go through both in terms of using both, because it will just extend the length of how long it takes me to answer the question. So I'm going to opt for the yellow versions. Now, if you do end up for the pink ones, it just may require you to, particularly with show that questions, to rationalize the denominator at the very end. And it might just be require that little bit of extra work. But if you are going to remember these trig ratios, like revising a spelling test, I definitely would certainly recommend revising the ones in the yellow box. So let's get started working through these questions. Now a little reminder, if you want access to these questions, all you need to do is just simply click on the link in the description below and it should be downloadable for free. So looking at question 1, it says write down the value of tan x for 1 mark. Now the first thing with this, we need to recognize what the ratio of tan x is. So tan x is the opposite over the adjacent. Now looking at this particular triangle, here is my angle x. So the side that's opposite that angle is 3. And the side adjacent to that x is going to be the 4. So here tan x is going to equal 3 over 4. So the answer is 3/4, or 0.75 if you want to go the decimal route. Then for question 2.8, it says write down the exact value of cos 0. Now typically when you're revising these, you don't really include the 0 and the 90, but it is still on the syllabus, so you still need to learn them. So ideally, if you can have some form of knowledge of the trig graphs, it will make all these types of questions that little bit easier. So the exact values of cos 0 rather is 1. The exact value of sine 90 is 1. And the exact value of sine 60 is going to be √3 over 2. Then moving on to 2D, it says write down the exact value of tan 30, and the exact value of tan 30 is √3 over 3, or 1 over √3, depending on whichever floats your boat. And then for 2E, it says write down the exact value of tan 45, and tan 45 is 1. Now again, just an insight of trig question, exact values of trig could be worth 1 mark, could be worth 2, could be worth 5. It really does depend. But I will definitely say that it's going to appear somewhere on that non-calculated paper. It just really depends on how many marks. So if you do find this topic particularly confusing and too much to remember, you can always run the risk of whether you do learn them, do you not. Look at the draw on how many marks it may be worth. Then moving on to question 3, it says work out the length of PQ. Now again, we can see that because we've got our angle as being 60, we know that could potentially be on a non-calculated paper, which this one is. So working out the length of PQ, so let's first of all highlight what PQ is, which is this line here, and let's start by calling that X. So then, knowing it's a trigonometry question because I've got two sides and an angle of a right angle triangle, so here I've got the hypotenuse, I've got the adjacent, so I'm going to be using cos. So cos X equals A over H. Then substituting those numbers in, I've got cos 60 equals X over 7. So then X equals 7 times cos 60. Now, knowing that cos 60 is one of the exact values of trig I need to know, and cos 60 is a half. So then this then becomes a half. So I've got 7 times a half. So then if I turn that 7 into a fraction, it then becomes 7 over 2, which is 3.5 centimeters. I can either write it as 7 over 2 or 3.5 centimeters. Moving on to question 4, it says work out the size of angle A. So looking at this, I've got the opposite and I've got the hypotenuse. So I'm going to be using sine. So sine of A equals, and it's going to be root 12 over 4. Now root 12, that can be simplified as a third. So root 12 is equal to root 4 times root 3. And root 4 is 2, so that becomes 2 root 3. So this then becomes 2 root 3 over 4. I can then simplify the 2, so I'm left with root 3 over 2. And then looking at my exact values of trig, looking at the sine row, which one gives me root 3 over 2? And root 3 over 2 is 60. So A equals 60 degrees. Then moving on to question 5, it says show that the value of 4 cos 30 times sine 60 times tan 45 is an integer. So first things first, let's start by working out these values. So cos 30 rather. So cos 30 is equal to root 3 over 2. We've got sine 60, which is equal to root 3 over 2 also. And we've got tan 45, which is equal to 1. So then substituting these three things into this equation, so I've got that there, this there, and that there, I end up with 4 times root 3 over 2, in which I'm just going to put all of these in brackets, multiplied by root 3 over 2, multiplied by 1. Then simplifying each of these, well, the 2 cancels with the 4, so that leaves me with 2. So this then becomes 2 root 3 times root 3 over 2 times 1. Then if I just simply convert all of those into fractions, so I get 2 times 1, which is 2. Root 3 times root 3 is root 9. And then multiplying all the denominators together, I get 1 times 2 times 1, which is 2. And the 2's then cancel. So all I'm left with is root 9, which is 3, which is my integer. Then moving on to question 6, it says simplify, and we've got 4 cos 60, tan 45, sine 60, and tan 60. So let's first of all write down what each of those values are in their exact form. So cos 60 is half, tan 45 is 1, sine 60 is root 3 over 2, and tan 60 is root 3. So then substituting each of those into this combination here, I've got 4 times a half minus 1 multiplied by root 3 over 2, all divided by root 3. So then let's work with simplifying this. So half times 4 is 2, so that becomes 2 minus 1, multiplied by root 3 over 2, all divided by root 3. So 2 take away 1 is 1, so that becomes root 3 over 2 over root 3. Now if you're not sure about how to then work with this, well, if I rewrite this as root 3 over 2 divided by root 3, I turn that root 3 into a fraction, and then I just use the rules of when you're dividing fractions by flipping the second fraction and turning it into a multiply. So then I get root 3 times 1, which is root 3, and 2 times root 3, which is 2 root 3. The root 3's then cancel, in which I'm left with a 1 at the top, so that leaves me with an answer of a half. So moving on to question 7, it says show that x equals a root 6 where a is an integer. Now in this particular triangle, x is one of the sides of a right angle triangle, and in order to find out what x is, I need to find what one of the other sides of this triangle is going to be. Now as one of the triangles that's got x has got an internal angle of 45, then the other angle is going to be 45, so therefore that this pink triangle is going to be an isosceles triangle. Now in order for me to find out x, I need to find out what one of the sides are. Now this side here is x, but I don't know what this side here is, and this side is attached to the other right angle triangle. Now if I take that right angle triangle out, and this here is 60, this is 8, and here is my right angle. This is the side that I need to try and find first. So from this, if I label the triangle, this is the opposite, this is the adjacent. So what I find is I've got tan 60 equals y over a. Now tan 60 is an exact value of trig, which is equal to root 3. So root 3 is equal to, and that's going to be y over 8. So y equals 8 root 3. So if I then take this pink triangle out and draw it over here, here's the right angle, that's 45, this is 45. This length here is 8 root 3, and these two sides here are x. Now in order to find x, I've got a few options I can do. I can either use sine or cos. Now if I use sine, I get sine 45 equals, and it's going to be x over 8 root 3, or I can have cos 45, which equals x over 8 root 3. Now even though we've got two trig ratios, sine 45 and cos 45 both equal the same thing. So sine 45 is equal to cos 45, which equals, and you can either recognize it as root 2 over 2 or 1 over root 2. So it doesn't really matter which one of those you use. For this, I'm going to use root 2 over 2, but most people use 1 over root 2, so you can use that one instead. So let's go for 1 over root 2 equals, and it's going to be x over 8 root 3. Now from this, if I do a bit of cross multiplying, because I've got a fraction equals a fraction, then what I end up with is I end up with x root 2 equals 8 root 3. Now if I take the root 2 over to this side, then what I end up with is x equals 8 root 3 over root 2. Then if I then multiply both the top and bottom by root 2, I end up with 8 root 6 over root 2 times root 2 is root 4, which is just 2. And then the 8 and the 2 cancel each other out, leaving me with 4 root 6. So x equals 4 root 6, which is exactly what they wanted me to show, and a equals 4. And there we go. Moving on to our last question, it says two different right angled triangles are put together. Calculate the length of y, give your answer in the form of p root 3, where p is an integer. So very, very similar question. So first things first, what I need to do is I need to work out that green line, which is connected to this triangle here. Now, because there's no angle involved in that green triangle, I've got to use Pythagoras. So if I just draw that triangle out again, let's call this side x. And I know that this is 9 and this is 12. So x squared equals 12 squared plus 9 squared. So x squared equals 144 plus 81. So x squared is going to equal, let me just quickly work that out, equals 225, which is a square number. So x equals 15. So then if I take that top triangle out, I know that this angle here is 30, this side here is 15, and y is what I'm wanting to work out. So I know it's going to be a trig question because I've got two sides and an angle. So this is h, this is a, so I'm going to be using cos. So cos 30 equals 15 over y. So then if I take the y over, so I end up with 30 cos 30, y cos 30 equals 15. So y equals 15 divided by cos 30. Now cos 30 is an exact value trig that I need to know, and cos 30 is root 3 over 2. So cos 30 equals root 3 over 2. So then taking y here, and again excuse my lack of presentation here, so that's 15 divided by cos 30, which if I, instead of using cos 30, I use root 3 over 2. So what that then becomes is 15 divided by root 3 over 2. I turn that 15 into a fraction, and then using the rules of division and fractions, flip that second fraction. So it then becomes 15 over 1 multiplied by 2 root 3, which then becomes 30 over root 3. Then if I rationalise the denominator by multiplying both the top and the bottom by root 3, I get 30 root 3 over root 9, which is 30 root 3 over 3. The 3 cancels with the 30 to leave me with 10. So then the answer then is 10 root 3, and that there is my final answer.